amino acids. As the name suggests, they have an amino group and they have a carboxylic acid groups, and that's why they are known as amino acids. Actually, amino acids are very important for our body because these amino acids are the building blocks of protein, and protein is building block of our body. So amino acids are very important biomolecules, and in this video we are going to study about these amino acids. So let's start. Amino acids. As the name suggests, amino acids are the molecules which contain two functional groups, amino group and acidic group, carboxylic acid group. So amino acid is a molecule which contains two functional groups. One is carboxylic acid, another is amino group. Amino acids are derivatives of carboxylic acids in which one hydrogen atom of carbon chain is substituted by amino group. Amino group may be at alpha, beta or gamma position with respect to carboxylic group. Let's understand this with example. Okay, so say we know that this is this type of compound are called amino acids. These contain acidic group and amino group, and these are amino acids. Okay, in this example you can see that amino group is present at alpha position with the carboxylic acid, so it is alpha amino acid. If it is present at beta, just like this, let's say CH2, COH, then CRH, and let's say NH2. In this case, it is present at beta position with respect to carboxylic acid functional group, so it is beta amino acids. So this is a general structure of amino acid. Different amino acid. Now this is a carbon which is attached to a carboxylic acid, a hydrogen group, an amine group, and a variable chain. The different alkyl chain results in formation of different amino acids, and these are those amino acids. If this R group, this was the compound NH2CH, it was R, then COOH. If this R is replaced by hydrogen, the compound form would be glycine, represented by GLY symbol, and one it would be G. If it is replaced by CH3 methyl group, it would be alanine. If it is represented by this isopropyl group, it would be valine. So depending on the different R group, this is the list of amino acids, 12 amino acids. Okay. Next is classification of amino acids. Based on a number of amino group and carboxylic acid groups, amino acid can be classified as acidic amino acid, basic amino acid, and neutral amino acid. Now let's see what are these. If there is a let's say this is the group, then there is CH, COOH, another group, and then there is an, let's say amine group. So from this, what we are seeing that there are two acidic group, but there is only one amino group. You know, amino group is basic in nature and acidic group is obviously acidic in nature. In this case, number of carboxylic acid functional groups is more than number of amino groups. So overall, this amino acid is acidic because there is more number of acidic group as compared to amino group. And if the situation is reversed, that means there is more number of amino groups as compared to carboxylic acid groups, just like this. There are two amino groups now and only one carboxylic acid. So in this case it is, actually this will be two. In this case it is, yes, a basic amino acid. And if the number of amino groups and acidic groups are equal, in that case it would be known as a neutral amino acid, which contains equal number of carboxylic acid groups and equal number of amine groups. Okay. Next is classification of amino acids. These are classified as essential amino acids and non-essential amino acids. Essential amino acids are those acids actually which are not synthesized within our body. We cannot synthesize them within our body. So we need to consume that in our food. They must be the part of our diet, otherwise we'll suffer from deficiency because we cannot synthesize those amino acids within our body. And that is why those are known as essential amino acids. They are very essential part of our diet because they are not synthesized in our body. So amino acids that cannot be synthesized in body and must be obtained through diet are called essential amino acids, and these are valine, leucine, isoleucine, etc. There are some non-essential amino acids which can be synthesized in our body, and these are like glycine, alanine, glutamic acid, etc. So on this basis they are classified as essential amino acids and non-essential amino acids. Now properties of amino acids. Actually amino acids are colorless and crystalline solids. They are non-volatile solids. They are not generally converted into vapor on heating. They are insoluble in organic solvents. They are all naturally occurring alpha amino acid except glycine are optically active. Glycine is not optically active. Other than glycine, all the naturally occurring alpha amino acids are optically active. Okay, now why glycine is not optically active? The good question is this. The structure of glycine is like CH2COOH NH2. Now there is no chiral carbon. This carbon attached to two similar groups, hydrogen groups, so it is not chiral. So this compound is not optically active. But if I talk about other amino acids, what happens that this hydrogen, one hydrogen is replaced by another group. Now this carbon becomes chiral, and that is why all of them are optically active other than glycine. Now amino acids exist in dipolar ion state, which is known as zwitter ion. Actually what happens, I have this amino acid actually, let me write it once again, NH2CH, let's say this R COOH. If the pH is acidic, in that case this proton will attack this amino group and it would be formed as NH4 positive CHRCOOH. If the pH is actually in basic range, then this acidic group will release the proton and the compound would be formed like this, NH2CHRCOO negative. So in case of acidic, in acidic pH, it exists as positive ion. In basic medium, it exists as negative ion. But there is some, at a particular pH, every amino acid exists as dipolar ion. Dipolar ion means what will happen that this, it was NHCHRCOO negative. This acidic group will release proton and that proton would be accepted by this amino group. So there will be both positive and negative ions within the amino acid molecule, but overall it would be neutral. So it will exist as dipolar ion but still neutral, and this ion is known as zwitter ion, and the pH at which zwitter ion exists is known as isoelectric point. This is isoelectric point. What happens that in acidic pH, this amino acid is attracted toward negative electrode because it is positively charged. In basic pH, this amino acid is attracted toward positive electrode because it is negatively charged. But at isoelectric point, they are not attracted by any of the electrode because they have both the charges but overall they are negative. So that point is known as isoelectric point. The point at which amino acid exists as zwitter ion, dipolar ion, is known as isoelectric point. In zwitter ion form, amino acid show amphoteric behavior, and the zwitter ion is dipolar, as we know. charge but overall electrically neutral, as I have just discussed that Zwitter ion is overall, as we know, Zwitter ion is dipolar, but overall it is neutral because it contains both positive and negative charges in equal amount also. So amino acids in dipolar ion form are amphoteric in nature, and depending upon the pH of the solution, amino acid can accept or donate the proton. Amino acids have minimum aqueous solubility at isoelectric point. Now, this is the list of isoelectric points of different amino acids. For neutral amino acids, isoelectric point is from 5.5 to 6.3 of pH. For glycine, it is 5.7. For alanine, it is 6.1. For valine, it is 6.0, and so on. So this table indicates the list of isoelectric points of amino acids, and every amino acid has a different isoelectric point, which is characteristic of that amino acid. Now, there is a solved problem. Which compound can exist as dipolar state? Obviously, that compound in which there is an free amine group and a free carboxylic acid group can exist as dipolar state, in dipolar state. And if I look for the options, I get is there any? This one, B. What would be the structure of B? Yes, it is CHCOOH. There is an NH2 group, then CH, which is further connected to CH3. So this can exist as dipolar ion in this form. So the correct option is B. Next is, which of the following amino acids is not essential one? We know valine is essential amino acid, leucine is an essential amino acid, isoleucine is an essential amino acid, alanine is not essential amino acid. So the correct option is C here. So students, we studied about amino acids. Also we know there are some amino acids which must be part of our diet because they are not synthesized in our body, and that's why they are known as essential amino acids, while some other are known as non-essential amino acids. In our next video, we'll move to protein. So stay tuned.